Okay, so it says if 2,200 square centimeters of a material is available to make a box with a square base and an open top, find the largest possible volume of the box. Okay, so if you like took this box, it's open on the top, and you like broke it down from these seams here and laid it flat, what you would get is what we call a net in mathematics. So like this base here would be a square, so it looked like that. And then you'd have the sides branching out of that. So there would be like one side like this. Right, we're assuming that I'm just saying, look, pretend like it's a long, narrow tube kind of thing, like a long, narrow box, like almost like a poster box you'd put a poster in or something. So if I fold all these four sides up, I get a tall, narrow box with a square base. Okay, so I only have like two measurements here. So this measurement here we'll call x, right? So this is x by x because it's a square base. So this distance is x, right? The only other distance is the height of the box. So we can call that y. Okay. So we're looking to maximize volume, which the volume of this box would be length times width times height, which would be x times y. So volume is going to be x squared times y. But I need to figure out a value for y. I know I have 2,200 square centimeters of material, so 2,200 is basically going to have to equal all of the faces, or all the faces of this net. So I have the center here, which is x squared, plus I have four rectangles of the same size that are all x by y. Okay, so I can solve this second equation for y. So I subtract x squared, divide by 4x. I get 2,200 minus x squared divided by 4x equals y. There you go. So now I can substitute. I get the volume equals x squared times 2,200 minus x squared, over 4x. I distribute the x squared. I get the volume equals 2,200 x squared minus x to the fourth over 4x. Okay, this can break down into two different fractions. So I do 2,200 divided by 4. So that's 550. I should have known that. 550. X squared divided by x, I'm left with x. Minus 1/4. X to the fourth divided by x, I'm left with x cubed. I just split it up into two fractions. So now I can take the derivative. V prime equals 550 minus 3/4 x squared. Okay. Set that thing equal to 0. I end up, if I add 3/4 to both, 3/4 x squared to both sides, I get 550 equals 3/4 x squared. Get rid of the 3/4. I'm going to do 550 divided by 3/4. That's not right. You got to do 550 divided by 3/4, like that. Yeah, 733. 0.3 repeating, so 0.33. Whoop, what's going on here? Equals x squared. Take the square root of that. $27.08. What did I say? 27.1, I guess. We'll just leave it at 0.8. Wants to know the volume. Okay. So that's x. I can find y by plugging that in here. Alpha y equals, enter, 2200 minus this squared divided by 4 times that. Nope. Oh, crap. Let's get rid of that. Let's see if I can fix this. We'll do answer like that. 13.54. Okay, so this is x. And 13.54 equals y. So my final answer is just going to be x squared. This squared times this. 9929.38 cubic centimeters.